Welcome back, Pre-Algebra. We're in Lesson 13. We're going to talk about factors again today. Most importantly, we're going to talk about the greatest common factor. You should remember that. But we're going to review it anyway, just to refresh our memories from last year. So we have common factors and we have greatest common factors. So to try to illustrate for you common factors, let's look at 12 and let's look at 9. So we have 12, and the factors of 12, I can say 1 times 12. I'll put 12 out here because it's a big number, and that's the biggest number here because it's the opposite of this factor, right? I can also say 2 times 6, and I usually like to go 1, 2, 3 if I can. If I start in order here, then these will be in order back here as I work my way towards the middle. I know that 12 can also be 3 times 4, and I know that 5 is not a factor at all, so I'm done because the next number was already 6, and that goes with 2. So there are no more factors of 12. So let's look at 9. So with 9, I can say 1 times 9, and then I can say 3 times 3. So those are all of my factors. Well, the factors that they have in common, I have a 3 here and I have a 3 here. So 3 is not only a common factor, but because it is the only factor that is in both sets, it is also the greatest common factor because it's the only one there. Greatest common factor, we often call it the GCF. And the greatest common factor of 9 and 12 equals 3. All right, so let's look at the GCF of another pair of numbers. Let's look at 24 and 7. Okay? 24 and 7. So 24, we have 1 times, I give myself some space, I write 24, right? I have 2 times 12. I have 3 times 8, right? And then I have 4 times 6. And that's it because 5 is not a factor. What about 7? Well, 7's a prime number. It only has one pair of factors, 1 times 7. So the greatest common factor between 24 and 7, the GCF, is going to equal 1. That's all you can do. Sometimes it is 1. Sometimes it's the greatest common factor. That's okay. It is what it is. So let's look at another pair of numbers. Let's look at 24 and 6 and see what those greatest common factors are. So 24, we could say 1 times 24. Actually, we've already got those factors here, so I'm just going to copy them. 2 times 12 and 3 times 8 and 4 times 6. So those are all the factors of 24. 6, I could say 1 times 6. And I can also say 2 times 3. And that's it. So there's a 1 and a 1. There's a 2 and a 2. There's a 3 and a 3. And there's a 6 and a 6, which is the biggest factor. What is the greatest number? The largest number? It's 6. So the greatest common factor for 24 and 6, the GCF, is equal to 6. All right, so you could see they could have multiple factors the same. The GCF is going to be the largest number that they have in common. All right. So let's jump into a example problem. Let's do 13.1. Let me clear the board for us. And I'm going to look at, oh, actually, that was 13.1. Sorry. So let's look at one more pair of numbers under 13.1. Then that would be 24 and 30. So let's see what the factors are. We know what the factors of 24 are. We've already done them a bajillion times at this point. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are the factors of 24. So let's look at 30. We have 1 times 30. Then we have 2 times 15. We have 3 times 10. We have, is there 4? No 4 times. We have 5 times 6. And that's it. Those are all the factors. So we have 1, we have 2, we have 3, we have 6, and that's it. So again, the greatest common factor here, the GCF of these two, is equal to 6. Very good. All right, so that was example problem 13.1, just in case you're wondering. Let me clear the page and we'll do another example problem. So 13.2, we're going to find the greatest common factor. Find the greatest common factor of 72 and 90. So let's start with 72. Let's look at that. So I know 1 times, let's put this way over here, 72, because I don't know exactly how many of these there are. 2 times, oh, let's see. Oh, my brain just shut down momentarily. I know this. 36. 2 times 36. That's what it is. All right, and then we also have 3 times, let's see, that would be 14 or 24. Let's try it. 24. No, let's try 14. 3 times 4, that's 12. Carry 1, that's 52. So it's not that. I think it's 24. 24 times 3. 3 times 4 is 12. Carry 1. 6. Oh, yeah, it's 24. So 3 times 24. And then we have, let's see, 72 divided by, can we divide it by 4? 4 into 7 is 1. That's 4. That's 32. 4 into 32 is 8. So yes, 18. So 4 times 18. So there's that. All right. We know 5 is not going to work, so we can skip that. But what about 6? I believe it's 12 times, or 6 times 12 is 72 from my times tables. And what about 7? No. What about 8? Let's see, 72 divided by 8. Will that go? That's the question. 9 maybe? 9 times 8? Yes, 9 times 8 is 72. So 8 times 9. And that's the last number. When you know you get two factors right next to each other, you know that's it. That's as far as you can go. That is the closest pair. Because it bridges the gap between the starting numbers and the ending numbers. So let's do 90. All right, so 1, and I'm going to put 90 way over here. 2 times 45, right? 3 times 30. So let's see, can we do 4 times something to get 90? No. 5 times 18. 6 times something. Can we do 6 times 15? I think so. 6 times 15. That's right. Can we do 7 times anything? No. 8 times anything? No. We can do 9 times 10, and that's as far as we can go. So now we can look for our common factors. We have 1, we have 2, we have 3, we have 6, we have 9, and we have 18, and that's it. Our greatest common factor is 18 because it is the biggest number. All right, so that's great, Miss Tracy. But what if I don't know all the factors? How do I figure it out? What if I miss one? What if I forget one? How do I do this? There is another way. Dun, 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 dun. Of course there is. So the way you can find the GCF is you don't have to have all of this memorized. It does help. Excuse me. But the way you can find the GCF is through prime factorization. So let's do the prime factorization of 72. Prime factorization of 72. So I could say 2 times 36, right? I know 2 is prime, 36 is not. 36 would be 2 times 18, right? So I'm going to replace that with 2 times 18. So 2 times 18. Well, I know 18 is not prime. That's 2 times 9, right? So I'm going to replace this with 2 times 9. And I know 9 is not prime. 9 is 3 times 3. So I'm going to take the 9 off and put 3 times 3. So there's my prime factorization of 72. Let's do 90. 90, that would be 2 times 45. 45 is 5 times 9, and 9 is 3 times 3. So there's my prime factorization of 90. Isn't that faster than doing all of this? I think so. I thought that was a lot faster. But how do I get my greatest common factor doing that? Well, what you have to do is find the pairs of factors that are the same, that are linked together. So I have a 2 and a 2, and I have a 3 and a 3, and I have another 3 and another 3. So I'm going to multiply the ones that were the same straight across. 2 times 3 is 6. 6 times 3 is 18. Right? 18 was our greatest common factor. This was faster. This was so much faster. Right? So that is how you can find the greatest common factor. You just find the pairs in the prime factorization and then multiply the ones that were the same for both. And then that is the greatest common factor of any two numbers you want to look at. And you don't have to try to rack your brain to think of all of the multiplication, especially when you have these big numbers that you might not have in your multiplication table, right? What if you have a really big number that's not in there, like 1,260? Well, prime factor it, and then you can find the greatest common factor without having to do all of that math in your head. And that is example 13.2. The alternative way to find the greatest common factor is to, first of all, do the prime factorization for each number. Second of all, find common factors. And then thirdly, multiply the factors of one set. So what I mean by that is, if you're going to multiply the factors that are circled for 72, you don't worry about these, because this will be the same. 2 times 3 times 3 would equal to 18, and then those numbers would be the same. But what you wouldn't do is you would not say 2 times 2 times 3 times 3 times 3 times 3. You don't multiply all of the ones that you've circled, just all of the ones in the same row, okay, or the same set. And that's your GCF. All right. So these are the steps you want to remember. Prime factorization, find common factors, multiply the common factors of one set of numbers. All right, so let's talk about the multiplication word problems. Some word problems require that numbers be multiplied to find the answer. Okay, we kind of expected that. Let's clear the page and try some. These word problems sometimes contain the word product. So we talked earlier about the names of the parts of a multiplication problem. And we know that we have a factor times a factor, and the result is a product, right? That's a multiplication problem. Factor times a factor equals the product. So 3 times 5 would equal 15. 3 and 5 are factors. 15 is the product, right? You remember that? Awesome. So when it says product in a word problem, that is a clue that we need to multiply. So let's look at our first word problem that uses product in it. Let me write it up here for us. All right, in example problem 13.3, we're going to talk about multiplication word problems. Harriet's score in the second game was the product of her first game score and 25. So, product of, that means what we're about to be told is going to be what we multiply to get the product. So her first game score is one factor, and 25 is the other factor. Okay? So we can say her first game times 25 equals the second game score. That's kind of our formula right here, because that's what product is telling us. If Harriet had scored 14,025 points in the first game, all right, this is the first game score. So we put that where first is. So 14,025 times 25 should equal the points for the second game. So I'm going to write that over here, 14025 times 25. And that's 5, carry the 2. It's 12, carry the 1. 0 plus 1, 20, carry 2. And that's 7. And then I multiply 2. I put my 0 in place. That's going to be a 0. I'll go ahead and cross all these out. I've already used them. I'm carrying the 1. 2 times 5 is 10. Carry the 1. That's 4, 5. 2 times 0 is 0. 2 times 4 is 8. And 2 times 1 is 2. 5, 2, 6, 0, 5, carry the 1, 3. 1, 2, 3, comma. So her score in the second game was 350,000 points, 350,625 points in the second game. And we got all of that because we were able to deduce from the word problem, from the word product, that we were multiplying the two. Right? It was the product of this factor and 25. and then it told us what this factor was in the second sentence. So all we had to do was multiply this times this to give us our answer. Awesome. So I am going to put another one up here. Give me just a second to write it. All right, so we're going to do something a little bit different with this problem. I want you to try to solve this on your own first. So let's read through it. 13.4, Roger scored 142 in the first game. He scored 7 times that many in the next game. How much did he score in all? So read the problem again to yourself. Pause the video and solve it, and then come back and I will work through it step by step, and you can see if you got the right answer the first time without my help to kind of gauge where you are right now. So go ahead and pause the video now, and then you can press play and see if you got the right answer. Okay, I'm going to assume that you pressed pause and that you worked out the problem. So let's see if you worked it out correctly. So the answer that you should have gotten was 209,136. That was what he scored in all. So if you didn't catch that in all and you didn't get that number, let's look at the problem again. Roger scored 26,142 points in the first game, right? In the next game, we'll call that the second game, he scored 7 times that many. So we could take 26,142 times 7 to find out how many he scored in the next game. 7 times 2 is 4, carry 1, that's 28, 29, carry 2, that's 9, 2 times 6 is 42, carry 4, that's 7 times 2 is 14, plus 4 is 18, so 182,994 points in the next game. So let's put that here, 182,994. That was the points for the second game. The question wasn't how many points did he score in the second game. The question was how many did he score in all. So that meant we had to add the points from the first game and the points from the next game together. And when we do that, we get, that's 11, carry 1, that's 9, that's 10, carry 1, that's 2. 209,136. Pay special attention to the word problems. The most important thing you can do with a word problem is to understand what it is asking for. Reread the one with the question mark, because that's the one that you have to answer, right? It could have given you all this information, and then the very last question said, how much did he score in the first game? Well, you wouldn't have had to do any math at all. You would just written this down, and that would have been the answer. So the question at the end of a word problem, the one with the question mark, is the most important one in regards to solving the problem, because that's going to tell you what math you need to do. So not only did we need to do multiplication here, we also had to do addition because we had to put these two values together. All right, so watch out for those, and that is all we have for lesson 13. I will see you in lesson 14.